When we're dealing with dissolved substances that are aqueous in a solution, it's often really important for us to be able to do calculations with those. And in order for us to do calculations with those, we need an understanding of concentration. Concentration is really just how much of a substance is dissolved in another substance. We often say that it's how much solute is dissolved in solvent. And there are lots of different measures of concentration, whether they be parts per million, parts per billion, grams per milliliter, kilograms per meter cubed. There's really tons of different ways to describe it. But in chemistry, it's really helpful if we talk about a unit for concentration that contains moles. You see, moles help us identify the difference between how much is in a substance and help us identify the amounts that will react throughout a chemical reaction. And so we're going to use a specific unit designed for concentration in chemistry. And this unit is called molarity, and it's often the unit that we're going to use in chemistry 30. So this is our equation for molarity, which is the molarity formula. It is that the molarity of a solution is the number of moles in that solution divided by the number of liters of solution. So essentially, it's moles of solute divided by liters of solution, and that is our molarity. Just to show you, capital M represents molarity. So it's important after a number that represents molarity, we write this as the unit after that number. MOL is an abbreviation for moles. Why? I don't know. That's just what they do. And capital L is liters. So now that we understand the molarity formula, let's take a look at an example. So suppose we had a 1.0 mole of sucrose and we dissolve it in some water. So basically you're making a nice delicious glass of sugar water and you keep adding water until you get 1 liter of solution. What would be the molarity of this solution? Okay, so I know that's too small to actually read in the corner, but just to remind you what was going on. To find this out, we need to take the number of moles. So our molarity is going to equal 1.00 moles divided by the number of liters of solution, 1.00 liters, and the molarity is 1.00, and then we represent that it is molarity with a capital M after it. Put a box around it to show that that is our final answer, and that's how we calculate the molarity. So you can see that was a pretty simple example. Maybe we should try something a little bit more difficult this time. So suppose you had 2.00 moles of solute. It's dissolved in 1.00 liters of solution. What is the molarity? So actually, we'll throw that back up in the corner there. Again, too small for you to read, but just a reminder what we're doing. So we, from the question, know the number of moles is 2.00. We know that the number of liters is 1.00. So we need to find the molarity. So we're going to use our molarity formula, which is moles per liter. So it's going to be 2.00 moles divided by 1.00 liters. It has a molarity of 2.00. Remember to put the M after it to show your units, our molarity, and there you go. All right, so now that we've done that, we have one more simple example before we try something a little bit more difficult. So what is the molarity when 0.750 moles is dissolved in 2.50 liters? So again, we want to sort out what we know, and what I know from my question is that I have 0.750 moles. I know that I have 2.50 liters, and I know I am trying to find the molarity because that is what's stated in the question. So that tells me I need to use my molarity equation, moles divided by liters. So it's going to be 0.750 moles divided by 2.50 liters. So next step, you punch this in your calculator. And when you do that, you are going to find that the molarity is 0.300 molarity. I'm keeping 3 significant figures because I had 3 significant figures in each of the numbers that were given to me. So there we go. Another example of how we would calculate straight molarity. But things are not always going to be this easy. So let's take a look at this example. What is the molarity of a 2.00 liter solution that has 102.44 grams of NaCl dissolved in it? Okay, so you can see this is going to be a little bit more challenging, but we definitely have the tools in order to work with this question. So I'm going to sort out the information that I know again. This time, when I read the question, I know the liters, and the liters are 2.00, so 2.00 liters. I also know the grams. I have 102.44 grams. And the last thing I know is that I am trying to solve the molarity. All right. Now, based on this information, I can't just divide as I normally have been. I have to figure out moles before I can do anything else, because the molarity of a solution is the moles divided by the liters. And currently, I want to know the moles, or the molarity. I know the liters, but I do not know the moles. Luckily, we know the number of grams, and using the number of grams, we can calculate the number of moles that we need. So we have 102.44 grams of NaCl. And keep in mind, we can convert moles or grams into moles using the molar mass. So 1 mole of NaCl has a mass of 58.44 grams. So to figure that out, keep in mind, I just added the mass of Na. So the mass of Na is 22.99 grams per mole. The mass of Cl is 35.45 grams per mole. Add those together and you get 58.44 grams per mole. When you do this calculation, grams of NaCl are going to cancel, and you're going to be left with an answer in moles. And so we are going to get 1.75, and you could keep going, you could keep more digits if you'd like, 29 moles of NaCl. So now that we know our number of moles, I can use my equation. So I have 1.7529 moles divided by my number of liters, so 2.00 liters. My molarity is going to be 0.876 molarity. Box my answer, and there we go. So if you're ever given grams, make sure to convert those grams into moles using a molar mass. Then take that number of moles and apply it into your molarity equation. Now that we've done a problem like this, I think it's time that we take a look at other things we can do with the molarity formula aside from just solving molarity. So one of the things we can do is, as long as we have information about any 2 of those values. So if I know moles and liters, I can calculate molarity. But if I know molarity and liters, I could calculate moles. And if I knew molarity and moles, I could calculate liters. So let's take a look at how we would actually do that. So in this example, how many grams of sodium hydroxide are contained in a 1.45 liter 2.25 molarity solution. So in order to do this, we first of all need to figure out how many moles of NaOH there are. So we were given grams. What that means is we can use the same method we used last time in order to figure out moles using the molar mass. And then step 2, we're going to convert from moles, or we're going to figure out from moles how many grams we're actually going to have. Sorry, I made a mistake there in step 1. We're actually going to use the molarity equation. Sorry, but it'll make more sense once I actually do it and we take a look at it under the camera. Okay, so in order to figure out the number of grams, we're going to need to know the number of moles. And in order to know the number of moles, I'm going to have to use my molarity equation. So the molarity is the moles per liter. But what I can do here is actually rearrange this equation to solve for moles. The way that I do that is I'm going to multiply by liters on both sides. Liters divided by liters is actually going to cancel out, and I'm going to be left with moles are equal to molarity multiplied by liters. And for myself, I always like to have the thing that I'm trying to solve for on the left. So I'm going to put moles over there are equal to molarity multiplied by liters. Now, if you really struggle with algebra and rearranging, you can actually use the triangle right here to help you determine how to solve this. So in order to solve, you put moles, molarity, liters. And the way that you use this triangle is you would say, okay, I need to solve for moles. So I cover up moles, and that is molarity beside liters. So that's the same as multiplying. Let's say I wanted to solve molarity. You cover up molarity, moles over top of liters. That's the same as dividing. And if you wanted liters, that's moles over top of molarity. So moles divided by molarity. So it's a quick little way to help you in case algebra is something you struggle with, but I would recommend make sure you can do some algebra because it is helpful later on when you cannot use something like this. Okay, so now that we know this information, we can plug in what we know from the equation. And so in the equation, it gives us 2.25 molarity multiplied by 1.45 liters. You just want to punch that into your calculator, come up with an answer. So what we're going to get here is this is 3.2625 moles. Now, I like to keep a lot of digits because I know I'm not done my question yet, because the next thing I need to do is step 2. Step 2 is take this number of moles and convert it into mass. So I'm going to take 3.2625 moles, and this is of sodium hydroxide. We want to convert this into a mass. So we're starting with moles. So moles is going to go on the opposite side of the equation, or the dividing line there, and this is going to be grams of sodium hydroxide. In a single mole of sodium hydroxide, there's 40.00 grams. I got this from adding up the molar masses of each individual atom in here. So 22.99 plus 16.0 plus 1.01 is 40.00. So 1 mole of sodium hydroxide has a mass of 40.00. And so then all we're going to do is punch in our calculator 3.2625 multiplied by 40, and we find there is 130.5 grams of sodium hydroxide. And if we were to round this to significant figures, it's going to be 3 significant figures. So that's going to be 131 grams of sodium hydroxide. And there you go. So you can see we can actually do a little bit more with this equation than just calculating molarity. So now that we see that, How about we do another example where that's the case? Okay, so what volume of a 0.20 molarity solution of NaOH contains 1.00 grams of sodium hydroxide? So here's what we're going to do is we are going to kind of follow the same steps. We need to figure out our number of moles in order to actually calculate the volume. Now, in order to find the number of moles, we were given the number of grams. So 1.00 grams of sodium hydroxide, we're going to convert into moles. So set up your time sign line, 40.00 grams. Remember that was from the last question. The molar mass of sodium hydroxide is 1 mole of sodium hydroxide. That will cancel out my grams and will leave me an answer in moles. So what you should get here is 0.025 moles of sodium hydroxide. Now, what we want to do here is we want to calculate the volume, and volume is measured in liters. So that means I need to solve for liters, and that is going to be moles divided by molarity. Quick tip here, one of the biggest mistakes is people go molarity divided by moles. So just make sure you have this correct before you continue. Then you're going to plug in your numbers, so 0.025 moles divided by the molarity, which was given to us in the question as 0.20 molarity. That's going to give you 0.125 liters. But if we read that question carefully, it's asking for this in milliliters. So what volume in milliliters? So to get milliliters from liters, we're going to move our decimal place 3 spots to the left, and you're going to get 125 milliliters. So you can see we can actually use this formula to do a lot, and it's all about the concentrations of dissolved substances inside of water, making sure that we're using moles, as that's the most effective unit when we're in chemistry. So thanks for watching. I hope this helped you understand how to use molarity. And up next, we'll take a look at how to use molarity to do stoichiometry.